Hello and a very good day to all judges and sales agents. Have you ever imagined that a small and cute robot arrives at your doorstep to deliver your food? But how will it help to improve the current situation that we are in now? So my name is Abdul Paiman.
My name is Nur Hayati.
Now present our project which titled Smart Delivery Robot Ecosystem. We are from Steve Technology Malaysia, GM, under the supervision of Dr. Wadi and Dr. Arif Hanan. This is our final product and electronically powered sidewalk autonomous delivery robot. How the idea of this project pops up during our study years in UTM. We have observed most of the delivery service that UTM students and staff usually use to have their food delivered at their current location. The current and usual delivery system use humans as the deliverers who ride on their motorcycle or cars. The more delivery orders, the higher the rate of harmful gas emission inside the ETM. Other than that, not all food stalls in the ETM are listed inside the food delivery mobile application, and most of that are listed inside the app are expensive restaurants outside the ETM with higher delivery charge. What is more worrying now is the current pandemic situation that urge all people to practice social distancing. Of course, handling the delivered food from hand to hand is not a good, really a good, it's not a really good practice. This problem statement have brought us towards executing this project idea into a reality and functioning prototype for the world to see one of the great innovation ideas.
Okay, as Takif said just now, it can be said that our project is environmental friendly, can cover all food stalls inside UTM, and also it helps to promote social distancing during this pandemic situation. Next, this is our target segment. The food stalls and other UTM people like students and staffs. The obvious impact that can be seen now is that it promotes social distancing between persons.
So this is our design methodology. It starts with the user give permission for the mobile app to track his location, and then he continues with the ordering process. This location is then saved into the Firebase and instantly sent to the robot or specifically to the robot brain. The robot will navigate from the top towards the user using a set of fixed waypoints until it reaches the user station. Along the way, the robot is powered up by three-level DC-DC boost converter to maintain a constant 12 volt power supply for a longer time instead of simply using batteries. This is the three-level boost converter as shown in the figure. It consists of two switches, two diodes, an inductor, load resistance, two capacitors at the output to form the voltage divider. Consequently, by choosing C1 is equal to C2, the voltage of the center point is half of V out is equal to V out over 2, and then the capacitors are generally added to the output so that the output voltage ripple is removed. In this converter, it is possible to operate two regimes depending on whether the input voltage is smaller or greater than half of the output voltage. So this is the first regime operation, which is a wave overlap. In the first regime, voltage input is less than the voltage, half of the output voltage. Then this figure shows the waveform operation of second regime. Okay. In the second regime operation, V input is higher than half of the output voltage. In this slide, it shows the analysis for modes 1 and 3 and also for modes 2 and 4. Okay, the equation for modes 1 and 2, 3, okay, as you can see, and also mode 2 and 4 by using KVL and KCL. After that, by using that equation, I'm using voltage. I'm using inductor volt second method to get the voltage conversion ratio, which is V out over V input equal to 2 over 2 minus is the duty cycle. And then at bottom there shows the calculation to find the duty cycle, which is equal to 2 times the time on divided by the period, where the period is equal to 2 over the frequency. And then it shows the analysis for size of inductor, so that in the converter is in continuous conduction mode. Then this is the analysis for size of the capacitor and also the calculation for the ripple voltage.
Okay, for GPS navigation, Arduino Mega receives localization information from GPS module and heading information from a compass module. As the master controller, it will then constantly compute the robot's pose using the information received, and then it correct the heading by adjusting the motor movement until the final waypoint is reached. Next, this mobile application act as an intermediate between the user and the robot deliverer. This app will obtain the user's current location and receives the unlock door and lock door command from the user. Firebase is an intermediate between the mobile app and the robot. Next, obstacle avoidance is the crucial thing for an autonomous mobile robot. Ultrasonic sensors are placed at front, left, and right side of the robot. The left side is to maintain a distance of 10 centimeters from the sidewalk of the road divider. Next, this camera is useful for real-time monitoring. This is a safety feature to avoid theft and for the developer to always observe the robot's navigation process. Next.
First, in the result illustration, this figure shows the open loop of the voltage at the desired voltage of 12 volts. Then, this is the closed loop of the voltage with 18 disturbance every 0.02 seconds.
Okay, this is the final product of our project. It can be found that the benefits is that it can travel from one place to another depending on the fixed waypoints and coordinate received by the user. Secondly, avoid obstacles along the way. Third, real-time monitoring and door lock for safety. And fourth, it can avoid close contact between humans and avoid harmful gas emission. But there are also threats in this project. First, the robot is dangerously exposed to passing by cars. Second, it has high possibility to run into humans. Third, it can experience a sudden power loss during navigation. And fourth, it has low resistance towards weather changes. And now we will proceed with our project demo video.
So this is the open loop circuit from the 3-level boost converter circuit. This is the waveform of the open loop output voltage. We go to the linear analysis. By using linear analysis, we can compensate the voltage to get our desired voltage at 12 volt. The oscillation is reduced. So after I'm using the linear analysis, I get by using the PID tuning, I get the value of the compensator. Then I insert it into the circuit. Then I get the closed loop of 3-level boost converter. Is the waveform of the closed loop of 3-level boost converter. Is the waveform of the output voltage after adding disturbance load every 0.02 seconds. Hardware part, okay, this is the schematic diagram which consists of charging, protection for the charging part, and also for the boost. Diagram for charging part, it consists of TP 4056. For the protection, I'm using DW01A. It need 2 MOSFET, 2 switches, using FS8 205A. for the boost part, I'm using MT3608. The V output formula, which is V out equal to Vref times 1 with plus R2 divided by R1. So in order to get V output equal to 12 volt with the V reference of 0.6 volt times with 1 plus R2 with 19 kilo over 90 kilo ohm or divided by 1 kilo ohm.
Based on the results shown in the demo video, some features are clearly shown and some are not, since this is just a prototype. In future work, it is essential to complete this system by introducing the store owner as one part of it, when they can receive the orders and payments and also interact with the robot with certain procedures implied. Furthermore, lane detection system is necessary, which it can detect the lines on the road and other physical landmarks that can help the robot to learn its surrounding. Mapping of a certain area is also an added advantage to further improve the navigation system. That's all from us. Thank you.